Have you ever stopped to wonder how every single tweet, every Instagram photo, every online transaction gets its own unique number, like instantly? Well, today we're pulling back the curtain on one of the biggest challenges in system design, building a unique ID generator that can handle the entire internet. We're going to dig into the really elegant solution from the book System Design Interview, so let's dive right in.
So, here's the big question. How do you actually do it? How do you assign a unique, sortable number to everything happening online? I mean, just think about it for a second. You've got millions of users on thousands of servers all around the world, all creating stuff at the exact same time. You need a system that absolutely guarantees no two IDs are ever the same, and, this is key, that they can be sorted by when they were created. Your good old database counter? Yeah, that would just completely fall apart.
You see, making that leap from a single cozy database to a global distributed system, well, it changes everything. The old rules just don't apply anymore. We need a new set of rules for a whole new game.
Okay, so here are the rules of that game, our list of requirements. First, our IDs have to be absolutely positively unique, no exceptions. Second, they have to be numbers, just plain old numbers, not a mess of letters and symbols. Third, they gotta be compact. Specifically, they have to fit into 64 bits. Fourth, and this one's a big one, they have to be sortable by date. An ID created at 3:01 p.m. has to be bigger than one from 3 p.m. And to top it all off, the system needs to spit these things out at a crazy rate, over 10,000 every single second. That's a really tall order.
So how in the world do we solve this? Well, before we get to the really clever solution, let's take a quick tour of a few other ideas. These are some common approaches that, seem pretty good on the surface, but as we'll see, they just don't quite cut it. First off to bat, multi-master replication. The basic idea here is pretty smart. You take a feature that databases already have, auto-incrementing numbers, and you try to make it work in a distributed way. So you have a bunch of master databases all trying to work together to hand out unique IDs. For example, you could have one server only generate odd-numbered IDs, and another server only generate even-numbered IDs. Simple, right? But here's the killer problem. The IDs aren't chronologically ordered across the whole system. You could easily get ID number 4 before ID number 3 is created on the other server, and that completely breaks our sortable by date rule. So this one's a no-go. Okay, attempt number 2. What about UUIDs, universally unique identifiers? I'm sure you've seen these before. They're these long strings of letters and numbers, and for a lot of developers, they're the default choice when you just need something to be unique. The chance of two different servers accidentally creating the same UUID is, well, it's basically zero. And UUIDs are fantastic for guaranteeing uniqueness, no doubt. But look at the cons. They fail almost all of our other rules. They're 128 bits long, which is double what we're allowed. They aren't sortable by time, and they're not purely numeric. So as great as they are for some things, for our specific problem, it's another dead end. All right, so if coordinating servers is so hard, what if we just don't? What if we centralize the whole thing? Let's imagine we create one single dedicated server whose only job is to hand out numbers, one after another, kind of like taking a ticket at the deli counter. We'll call it a ticket server. And you know what? This almost works. It gives us nice, clean, numeric, ordered IDs. But it has one massive glaring problem. It's a single point of failure. If that one server goes down, the entire system grinds to a halt. No one can post anything, anywhere. You could add backup servers, sure, but then you're right back to the same old synchronization headaches. For a global service that needs to be on 24/7, this is just not an option. So after watching these different attempts stumble, it's pretty clear we need a totally different way of thinking about this. And this quote really sums up the mental shift we need to make. Instead of trying to get one single source to generate the entire ID, what if we build the ID from smaller, separate pieces? What if we divide and conquer? And that right there leads us to the breakthrough. It's an approach that was famously pioneered by Twitter, often called the snowflake ID generator. And this is where things get really, really cool. See, instead of being just one big number, the snowflake ID is actually a composite. It's made of several different parts, all cleverly packed together into just 64 bits. You've got a section for a timestamp, a part for the data center ID, another for the machine ID, and finally, a little counter called a sequence number. Each tiny piece has a very important job. Okay, let's break it down. First, the biggest part, the timestamp.
That's 41 bits dedicated to storing the time in milliseconds. This is the magic that makes all the IDs sortable. Next up, we have bits for the data center and the specific machine that's generating the ID. This is what guarantees uniqueness across your entire fleet of servers. And finally, that little sequence number. That's our secret weapon for handling insane traffic bursts. When you need multiple IDs from the same machine in the exact same millisecond.
So we've got 41 bits set aside for the timestamp. Now, you might be wondering, okay, but how long will that actually last? Don't we eventually run out of numbers? That's a great question, and the answer is pretty amazing. 69 years. By setting a custom start date, what they call an epoch, this system is designed to keep on working for decades. That is some serious future-proofing built right into the design.
And hey, remember that crazy requirement of generating over 10,000 IDs per second? Well, let's look at that 12-bit sequence number. That gives us 4,096 unique combinations. But here's the thing, that's not per second. That's 4,096 unique IDs per millisecond, per machine. That's over 4 million IDs per second. Our original requirement is just left in the dust. This thing is built for absolutely massive scale.
So, we've got our solution. It's robust, it's scalable, it's elegant. Let's just take a step back for a moment and really talk about why this divide and conquer approach is so powerful.
And here's the real key takeaway. The genius of the Snowflake ID is that it solves a bunch of hard problems all at once by assigning each problem to its own little section of that 64-bit number. The timestamp makes it sortable, the data center and machine IDs make it unique across a distributed system, and the sequence number lets it handle incredible bursts of traffic. It's just a beautiful, beautiful piece of engineering.
But of course, no design is perfect. There's always a catch, right? For this entire system to work flawlessly, all the server clocks across the entire world have to be perfectly synchronized with each other. And let me tell you, clock synchronization is a notoriously tricky problem in distributed systems. It's a great reminder that whenever you solve one problem in system design, there's usually another fascinating one waiting just underneath. So the next time you see a post ID on social media, you'll know about the incredible, elegant engineering that's happening behind the scenes. And it really makes you wonder, doesn't it? What other invisible engineering marvels are powering our daily digital lives? Thanks for joining me for this deep dive.